In this video, we're going to look at multiplying and dividing radical expressions. So let's begin with just some very basic radical properties. So let's write these down. Radical property number 1. If you have the nth root of a times the nth root of b, as long as you have the same root, you could rewrite this as the nth root of a times b. Let's give this a number. How about we'll call this number 1. Number 2 says that if you have the nth root of a, that doesn't look like an n, it looks like a scribble, the nth root of a divided by the nth root of b, you can rewrite this as the nth root of a over b. And then the last property is for rationalizing the denominator. Rationalize the denominator. If you have the square root of a over the square root of b, or we can call this really any root, any nth root, to rationalize the denominator, you multiply by whatever's on the denominator, top and bottom, like so. And then this becomes the square root of a times b over just b, because you know you can think of this as the square root of b squared, where the square and the square root cancel each other out. And that's how I got that b down there. All right, so those are the 3 properties we're going to need to work with today. I just want to rewrite this 3 here. That was bugging me. Okay, so let's do some examples. Those are the 3 properties. That's all we need to know for today. So example number 1. Let's do some examples. Example A. Let's take the third root of 6 and multiply it by the square root of 2. The third root of 6 times the square root of 2. Wait a minute. We can't do this. That's impossible. There's no solution to this. The multiplication here doesn't exist. Why? Because they don't have the same root. We have different roots. When you have different roots, you can't multiply those things together. Let's take a look at another example. And in this example, we're going to take a look at the third root of -4 times the third root of 2. Oh, time out. Can I take the third root of a negative number? Yes, I can. Look back in your notes from 6.1. As long as your root is odd, you can take an odd root of a negative number. Say that again out loud. You can take the odd root of a negative number. All right, so anyway, let's get going here. We're going to look at this as the third root of -8. The third root of -8. I'm going to rewrite this as the third root of -1 times 8. I'm going to rewrite it again. The third root of -1 times 2 to the third power. So 8 is 2 to the third power. So I liked separating out that -1 just because, you know, -8 is kind of any negative number is a -1 times itself. So whenever I see a negative, I always think, well, that's really -1 times some natural number, some counting number. Okay, so the third root of -1 is going to be a negative, and then the third, or -1, and then the third root of 2 to the third is just going to be 2. My final answer is going to be -2. The third root of -1 gave me the negative, and then the third root of 2 cubed, the third root and the third power canceled, and I was down to just -2. All right, I liked that example. Did that hurt your brain? Good. All right, I'm going to go with a pretty purple pentatonic of pride, purple letter C. Let's take a look at the third root of 54, x to the 5th power. All right, hear me out. I'm going to think of 54 as, what is 54? Well, it's even. 54 is actually 2 times, where's my pen, 27. Okay, 2 times 27 is 54. And then x to the 5th is really, let's call that x to the 3rd and x squared. See what I did there? I busted up the x to the fifth. And I did that intentionally to suit my needs. I want something with a third power. Everything that's left is just kind of stuck underneath this radical symbol. And then 27 I know to be 3 to the third. So maybe you want to erase 27 and write in 3 to the third, or maybe you want to rewrite this problem. I should have probably rewritten 2 times 3 to the third times x to the third times x squared. So 27 is 3 to the third. That's another one of those things by the end of the month, you're going to know that 27 is 3 to the third, like the backside of your hand. All right, third root, third power cancels. I've got a 3 outside. I've got an x outside, third root, third power. And then I'm left with the third root of 2x squared underneath the radical symbol. Okay, that was a fun one. Let's do another one. We are covering a lot of ground here in not much time. I'm going to use another color here, and let's go with letter D over here. This time, I'm taking a look at 72 x cubed y squared, and I'm going to multiply this by the square root of 10x y to the third. All right, so write that puppy down. You're multiplying these two radicals. Then as long as the roots are the same, and they are, square root, I can multiply everything together. So 720, 72 times 10. X to the fourth, y to the fifth. X to the third and x, I'm going to add those together. Y squared, y to the third, add those powers together, y to the fifth. Now, I want a perfect square, you know, to kind of like, I don't know, suit my needs here. I think, I don't know, should I just start plugging in square roots, or should I do a factor ladder? I guess I'm going to do a factor ladder because I'm thinking you might be more comfortable with the factor ladder. So 2 goes into 720 360 times. There's my perfect square, 36. What else do I know? I know that, well, what do I do? I'm going to go 36 and 10. Now this goes against all the rules because I did not use a perfect square there. 36 is not a perfect square, but I mean, I didn't use a prime number. 36 is a perfect square. It's not a prime. Okay, so check this out. I'm going to rewrite this as 36 times 4 times 5. I like it. 36, 2 times 2 is 4, and then I have a 5. I'm looking for a square root. So what I really need to be able to do is cancel out a square and a square root. So I'm going to rewrite x to the fourth as x squared squared. I'm going to rewrite y to the fifth as y squared squared times y. There's my 4 and 5 y's, the way I broke that up. Then cancel your squares and square roots. So 36 square rooted, or in other words, the square root of 36 is going to be 6. The square root of 4 is 2. The square root of x squared squared is going to be x squared. The square root of y squared squared is going to be y squared. And then what am I left with? I'm left with a 5 and a y. So then underneath the radical, underneath the square root, I still have 5y. Okay, that's my final answer. I could also have written that as 12 x squared y squared, square root of 5y. All right, so that was kind of a tough one because we had to multiply first, and then 720 was a big number. I don't know if I love the way that I broke down 720, but I really want us to get into the habit of, if we're looking for a square root, are there any squares in that number? And I just so happen to know that 72 divided by 2 is 36. So 36, I don't know. All right, we're going to get more practice, don't worry. All right, 2 more examples. Hang with me. Remember, we're just kind of baby stepping our way through this chapter. So you're watching the video, you are taking some good notes. Tomorrow in class, we're going to practice, and we are all on this beautiful slow journey together, as my yogi would say. All right, square root 18x to the 5th over 2x to the 3rd. So all underneath one radical. Can you divide 18 divided by 9, or 18 divided by 2? Yes, that's 9. X to the 5th over x to the 3rd. How would that simplify? That's going to simplify into x squared. Remember, the division bar, exponents, see that giant division bar as a minus sign. So 5 minus 3 gives me x squared. And then go one more step. What's the square root of 9? 3. What's the square root of x squared? Just x. So the square root of 9x squared, 3x. I don't know about you, but I just love the way this makes my brain feel. Like, I love it. I'm good at it. I want you to be good at it. I want you to love it as much as I do. All right, and then here we go with letter F. This time, we're going to take the 3rd root. I'm going to put this 3, come on, erase number 3. I'm going to put the 3 here on the tail of the radical. And inside here goes 162y to the 5th over 3y to the 2nd. Okay, so along those same lines as I did in letter E, I'm going to begin by dividing. So what is 162 divided by 3? It is 54. And then those exponents are going to see that division bar is a giant minus sign. 5 minus 2 gives me y to the 3rd. So 54. Well, 54, if I divided that by 2, I would get 27. So 54 divided by 2 is 27. I'm so happy to see the number 27, because what is 27? 27 is 3 to the 3rd power. All right, take it home. What's it going to be? This is going to be 3y times the 3rd root of 2. Very good. All right, that's all she wrote. I am going to stop it there, and we'll pick up tomorrow.